In this lesson, we're going to examine the solutions to quadratics. We're going to try and solve a quadratic. It's a refresher from last year. So some reminders. If you want to solve a quadratic, the equation has to be equal to 0 and in standard form. You're then going to try and find your zeros. We also call our solutions x-intercepts, roots. If you can factor, try factoring. Factoring will get you a nice, easy way to get the zeros if you can. So if you see x plus 4 and x minus 3 and it's factorable, you can figure your two zeros. If you can't, we'll go to the quadratic formula. It's obviously a little bit messier. You need a calculator for that. It takes a little bit longer. But if you have to, we have to. Just remember the A, B, and C come from standard form. So make sure it's in the right order before you start. So let's try a couple. Okay. Rule number 1, got to be equal to 0. First one is. Rule number 2, it's in standard form. And this one is in standard form. Our A value is 1, B is 8, C is 12. It's ready to go. So our first choice is, can we factor this? And I look at this and I think to myself, well, this is man. Can I multiply to 12 and add to 8? And I can do that if I use the numbers 6 and 2. So my factored form of this equation, x plus 6, x plus 2. And that's my factored form. My zeros, my solutions, are negative 6 and negative 2. And I like to put the arrows in there to remind myself I'm not done until I actually write down the answers. And we'll try the next one. Standard form, yep, equal to 0, perfect. Try factoring. Is there anything that mans this one? Multiplies to 48 and adds to 20. And I think to myself, well, 16 and 3 gets close, but not quite. 2 and 24, 8 and 6. I can't think of anything, not very quickly anyways. So give yourself 10 seconds. If you can't figure out which numbers work, or maybe there aren't any numbers that work, let's go to the quadratic formula. So again, A, B, and C. Our quadratic formula is negative B, so negative 20, plus minus the square root of B squared minus 4 times A times C. And be careful with your signs, they're all important. All over 2 A's. So first step, put the right numbers in the right spots. Second step, figuring out the number underneath the root sign. So do all the calculations of the root sign. So 20 squared minus 4 times 1 times 48. And hopefully you get 208. And at the same time, figure the number underneath the fraction. And it should be 2. Reminder from last year, you have two separate answers here, right? You have negative 20 plus the root of 208. Figure what that is. Then divided by 2. If you do that, you should get negative 2.79. And you have x equals negative 20 minus the root of 208, all divided by 2. And if you do that one, you should get negative 17.21. You don't have to show this line here. I'm not really worried if you show this line. I'm just trying to remind you that you do have two separate answers. The formula is great, but hopefully not reliant totally on the formula. You want to try and factor if you can. Try a couple more. Here's C, and here's D. So, standard form equal to 0. Letter C definitely looks like that. Can I factor this? Oh, I got two terms, I got a minus sign between them, and I can square root. So yes, I can factor. This is a difference of squares. Two terms, opposite signs between them. What are the zeros? Well, if I can't look at it, I can always solve it. So I got x is 1.5. This one's the exact same thing, so it has the opposite sign, right? So negative 1.5. Letter D, standard form equal to 0. Well, that's not true, so let's fix it. Our choice is either move everything to the right or move everything to the left. The way I decided is where my squared term is. I prefer to keep my squared term positive. So I'm going to move everything to the left. So x squared minus 18x plus 40 makes 0. Standard form. All right. I got A, B, and C in the right spots. Looks like a trinomial. That's tri-man. What multiplies to 40 and adds to negative 18? So I'm thinking somebody might say to themselves, well, 20 and 2 do that, except 20 and 2 have to be both positive to make 40 or both negative to make 40. And if they have different signs, they won't make negative 18. So, unfortunately, This one's not manable. Can't factor it. Back to the formula. The negative of b. b is already negative, so let's make it a positive. Square root of b squared, make sure it's in brackets, minus 4 times a times c all over 2a's. Math underneath the root sign, 18 squared minus 4 times 1 times 40 gives us 164. On the bottom we get 2. Let's get our two separate answers. The adding one, I believe, is 15.4 of my calculator. And when I do subtracting, I get 2.6. Okay, we've solved those ones. A couple more simple ones. Okay. Our two rules are standard form equal to 0. These two questions definitely don't look like that. So we need to work on our algebra skills. We need to rearrange these things. What can we do? Well, we can get rid of brackets first of all. I see a bracket squared. I write it out twice. I see a bracket and a number in front. I know I can distribute. It gets rid of one set of brackets. If I FOIL the left side, I'll get x squared, 3x plus 9 minus x. And I know I want to make it equal to 0, so I'm going to bring everything to the left. So minus 3x and minus 33. Notice I got rid of the brackets first before I did that. It's always better to get rid of the brackets before you start rearranging left side to right side, because it can be awfully confusing. We're left with nothing on the right, kind of the way we want it. If we collect, we'll get 3x plus 3x, which is 6. 6 minus 4 is 2x's. And 9 minus 33 is minus 24. It looks like a trinomial. Can we man this thing now that's in the right order and equal to 0? And then multiply negative 24 and add to 2? Sure. 6 and negative 4. So x plus 6, x minus 4, that's factored, that's solved. Solutions are negative 6 and positive 4. Okay, but the key there was it was in the wrong order and it wasn't equal to 0, so we had to fix that first. Let's try the same thing in the next one. Let's see a bracket squared. Write it out twice. The 20, I want to come to the left, so it comes out to 0. I can bring it right over because there's nothing else happening with that 20. Let's FOIL our brackets. X squared plus 1x plus 1x plus 1. The 20 is outside, let's leave it alone. Let's expand or collect. It doesn't really make a difference which order you do this in, because either way it's 2 steps. And 4x squared plus 8x plus 4 minus 20. Okay, not quite in the right order because we got 2 numbers at the end that can be collected. Now it's good to go. Let's try factoring first. Factoring is always preferable. I look at these numbers and I think to myself, they're all divisible by 4. Now somebody, again, might think to themselves, well, why would you multiply by 4 and then divide by 4? Because we did multiply by 4, right, back here. But the 20 wasn't involved in that. So it's not like we're redoing the question again. And we just didn't have that 20, so we had to collect like terms. If I look at the bracket, I think to myself, is that manable? Is it a simple trinomial? Unfortunately, nothing multiplies to 4 and adds to 2. So back to the formula we go. X equals negative b plus minus b squared minus 4ac. Now, I'm using the numbers inside the brackets. You also could have used the unsimplified format if you wanted to. That would be this line for your quadratic formula. It'll give you bigger numbers in the interim, but the exact same answer in the final. Okay, underneath the root sign, we're going to get 20. Under the fraction, we get 2 answers. Positive one, I believe, is 1.24, and negative 3.24. And that's some solving of quadratics. We want to be able to apply this, obviously, to different situations. So let's look at some simple word problems, ones that should be familiar kind of things. Okay, the first one, we got ourselves a rocket ship that's being launched. Generally, rockets follow parabolic curves, a parabola, quadratic. Okay, and they give us the equation of our height based on time. So our equation, our graph, is going to look something like this, right? Height and time. How long is the rocket in the air for? So basically, where does it start and where does it end? because the difference between those will be how long it's in the air for. What do we know about when it's not in the air? We know it has a height of 0. So, can we solve this equation is what we're being asked. Let's try factoring. Look at this and you think to yourself, hopefully I can common factor this. I can take a negative 10t out of everything. If I do that, I get t minus 20. What are my zeros? Well, one of them is 0, and one of them is 20. Obviously, 0 is where it started, 20 is where it ended. It was in the air 20 seconds. Okay. But I had to recognize that I know the height has to be 0, and I can factor this thing. When does it reach its maximum height? Well, that's an optimal value. We know how to find optimal values. We find our axis of symmetry, which in this case is halfway between your zeros. And that gives us 10 seconds, which kind of makes sense, right? And there's where our maximum will happen. What is the maximum? We've done that before too. Our height at 10 seconds. We'll plug the right things in the right spots. And I believe this comes out to 1,000 meters. And then we got ourselves our vertex. Kind of the common things we've been doing. When will the rocket reach a height of 640? The first thing you want to ask probably is, does it reach a height of 640? And we know it reaches a height of 1,000, so 640 would be somewhere around here maybe. When does it reach that height? What can we do to figure that out? Well, we know the height has to be 640 at some point. So let's put that into our equation for h. The rest of the equation is the same. I need to solve this. How do I solve quadratics? I make them equal 0 and I put them in standard form. So I'm going to move everything to the left. So negative 10t becomes positive, the 20 becomes negative, and the 640 stayed where it was. So it's in the right format and equal to 0. I'm going to try factoring. Always try and factor first. It's faster. So if I take out a common factor, hang on, I think I wrote down the wrong equation. Yeah, I missed a 0 in there. It should be 200t, not 20. 200t, 200t. Take out the 10 first, and then say to yourself, is this manageable in here? Is there anything that multiplies to 64 and adds to negative 20? And sure enough, there is. The numbers are negative 4 and negative 16. So t minus 4, t minus 16. Are those the answers? No, that's my factored form. 4 and 16 are my answers. Why are there 2? Well, if we go back to our picture for a second, on the way up, we hit 640, and on the way back down, the symmetrical point, we hit 640 again. Okay, so when does the rocket reach a height of 640? Add both, reaches 640 meters at 4 seconds, and again, on the way down, at 16 seconds. And then if we go to the last part, it says, how long will it be above 644? Well, it's above from 4 to 16. So how long is that? So for part E, from 4 to 16, or in other words, 16 minus 4, or 12 seconds. That's how long we're above 644. And that's kind of our standard quadratic. Now, in class, we may or may not have time to get through this one. If we do, great. If not, there's an extra bonus one you can look at. So we got Mark. He has a summer tree trimming business. His profit is based on this equation, where X is the amount he charges per tree. So we want to know how much to charge if he wants to break even. Break even is a term we talk about lots. That's where our profit comes out to $0. So in other words, we need to solve the equation that comes out to 0. Give it a try. Standard form, equal to 0, good to go. Let's factor it. Let's get rid of that negative 4 if we can. If we do, we end up with negative 25x plus 150. Is that manageable? Anything multiply to multiply to 150 and add to negative 25. You think of any numbers that do that? Well, I think -10 and -15 work. So if we put those into our brackets, we'll get x minus 10, x minus 15. What are the answers? Well, they're either 10 or 15. So there's two different prices he could charge. He could charge either $10 or 15. Odds are if he charges 10, he'll cut a fair number of trees down. If he charges 15, he'll make more money per tree, but probably cut less trees down. And that's usually how money models work with quadratics. What if he wants to have a profit of 25 bucks? Just make a little bit of money. Can we do that? Sure we can. Same equation, but this time we want our profit to come out to 25. So 25 equals -4x squared, same equation, plus 100x minus 600. I want to make it equal 0, so I'm going to bring everything to the left this time. We got 4x squared minus 100x plus 600 plus the 25 that's over there already. And that gets me 4x squared minus 100x plus 625. Is this factorable? Well, it looks like a complex trinomial this time, so they can't divide by 4. But maybe, just maybe, you might notice that this is a perfect square, and so is that, which might suggest we can do a perfect square. Square root of 4x squared is 2x. Square root of 625 is 25. And 2 times 25 doubled makes 100. So this is a perfect square. So what are our answers? Well, let's see what makes this equal 0. X has to be 12.5. So if he wants to make just that minimum 25 bucks, he needs to charge $12.50 to make $25 in profit. Okay, quick reminder how to solve some quadratics. Nothing new here today, we're just solving. Okay, the questions are in the book. Do these ones, but in question 4, just solve, regardless of what it says in the questions, just solve. Okay.